So in the previous video we learned how we can reduce the height and the width using the stride parameter. And in this video we are going to talk about a technique called padding that allows us to control the output size more precisely. So when we are designing our own convolutional neural network architectures, it's often helpful to calculate the feature map sizes. So here's the formula to compute the output width of a feature map. We can, by the way, use the same formula to also compute the output height. So let's take a look at the variables that determine the output width. First of all, we of course have the input width. Then we have the kernel width that we subtract from the input width. We have this padding parameter that we will talk about in a moment. And we have the stride that we divide by. So let's take a look at a concrete example where we have an input of width 100. So for the kernel, we use a height and width of 3, and we use 0 padding with a stride of 1. So if we plug in these values into this formula as shown here, the output width will be 98 pixels. To illustrate that PyTorch adheres to this formula, let's actually try this out in PyTorch. So using a random 100 times 100 input, let's apply a convolutional layer and see what the output height and width are. And as we can see here at the bottom, the output height and width will be 98, just like what we computed using our formula here. So let's take a look at another example where we change the kernel width from 3 to 5 and we increase the stride from 1 to 2. Now if we plug in these values into the formula again, what we get as the predicted output width is 48.5. So in this case we get a non-integer result. So let's plug in these values into PyTorch and see what we get. So what we can see here as a result is that we get a 48 by 48 output feature map. So how does that work? So in fact, we forgot one little thing here in our formula, and that's the flooring operation. So automatically what will happen here is that PyTorch will round down to the nearest integer. So in this case, when we round down to the nearest integer, we convert 48.5 to 48. So yeah, we have just seen the formula that we can use to compute the output width. And we've seen that padding is one of the variables in this formula that influence the output width. But what is padding exactly? So for example, if we have a padding of 1, what we do is we add one column of zeros to the left-hand side, one column of zeros to the right-hand side, and a row of zeros to the top and to the bottom. Similarly, if we had a padding of equals to 2, we would add 2 columns of zeros to the left-hand side, 2 columns of zeros to the right-hand side, and then 2 rows of zeros at the top and at the bottom. So padding is essentially adding a frame of zeros around our input. So let's illustrate this with an example. Assume on the left-hand side we have an image without padding, and on the right-hand side we have an image with a padding of equals to 1. So you can see on the right-hand side we add this frame of zeros around that input image. Now suppose we are creating the feature map, for example using a convolutional layer or a pooling layer, and we have a kernel size of 3 by 3. So now we are sliding with a stride of 1 over this input image, and you can see if we have 0 padding, we will get 3 output pixels in the feature map. Now if we do the same thing with padding, you can see how it influences the output size, because now we have 5 iterations here over this input image. So using a padding of 1 here, you can see that the output feature map will have exactly the same width, 5 pixels, as the input feature map. So in this video we have seen how we can use the padding parameter to control the output size. However, if you don't want to do the math and you want to, let's say, produce an output feature map that has the same height and the same width as the input feature map, in PyTorch you can also now use the padding equals to same parameter to produce a same sized output feature map. Alright, so in this video we talked about a formula that we can use to compute the dimensions of the output feature map. This is super useful if we are designing our own convolutional neural network architectures. However, in practice, it's actually very common nowadays to use predetermined convolutional neural network architectures, and in the next videos we will take a look at some of these commonly used CNN architectures.